Welcome back to the video series of CCA 175 certification preparation. In this video, I'm going to provide a solution to problem 1 posted on my blog. As I have already mentioned in the introduction video, this is not a tutorial. I'm assuming you've already spent a week or two in understanding and gaining basic knowledge of Scoop, Flume, Spark, Hive, and HDFS. A good understanding on how to use these tools or APIs is very important before you appear for the certification exam. My goal is to create a series of posts and accompanying videos that solve fabricated problems in order to validate your attained skills in the mentioned areas. Before we get started and solve this problem, here are 2 important tips for your exam. There are some important pieces of information in the questions. Do not try to type things such as folder names and passwords. There is a good chance you may mistype them. Always use copy-paste to copy folder names and other data that is needed for the solution. Read the question carefully and completely. I do not know how Cloudera validates a solution, but I can assume they may use automated scripts. Hence, A space B is never equal to A 2 spaces B. So remember that. Let's read the first part of the problem and get into the solution. The first part of the problem says, using Scoop, import orders table into HDFS to folder orders. So we need to copy the folder name as I mentioned before. The file should be an Avro file and use snappy compression. Let's go to the terminal and check if the folder exists. If the folder does not exist, we are good. If the folder does exist, then we need to remove the folder. The folder does not exist. Let's go back to the blog and copy the scoop command I've provided as a part of the solution. The scoop command already addresses storing as Avro file and compression codec. Let's take a break while it is running and return when it completes. Looks like the scoop command finished execution. Let's validate if the scoop command has in fact copied the data into the folder that we mentioned, that is user, Cloudera, problem 1 and orders. Yes, I can see 4 files and all those are Avro files as we have requested Scoop to do. The next part of the problem is to download or pull the data from order items table into order items folder using snappy compression. This time let's try to understand what we have written on the scoop command. So let me copy it from here and paste it over here. Now if you look at what we have written on the scoop command, you will see the scoop import, the connect username, password and table. Each of them provide information about what we wanted to download and from which database. There is a compress and compression codec, and if you notice, I've used snappy codec based on what was written in the question. The target directory is order items and I want to download it as an Avro data file. Now that Scoop has finished execution, let's check the order items folder if the required files have been stored. Yes, I can see 4 files under order items as well. Now let's go back to the problem and find out what's our next step in the problem. So this says, using Spark shell, load the data as data frames. Now in order to load data as data frames, you will have to use the Spark shell, not the Spark scaler, but Spark shell. So let me try the Spark shell and hit enter. Let's try to load that data as data frame. So let's do var odf equals SQL context dot read dot avro. Now this command is going to fail. I'll tell you in a minute why this is going to fail, but let me just copy the folder from which the data needs to be accessed. The reason why this failed is because the version of Spark we use does not have a default capability to load Avro files. For this, we need to import some special classes. com.databricks.spark.avro._. This imports all the files, all the classes under the Avro package of com.databricks Spark package. This is going to take a little more time than normal because this is the first time we are loading a data frame, because there might be some initialization aspects and there might be certain things that need to be done for the first time. Now let's try to load the order item data frame just by changing the path and changing the variable identifier. As you can notice, this time it loaded faster. Now order data frame has order ID, order date, and a couple of other fields which are very important for our problem here. And order ID data frame has order item subtotal. Now remember that these are two different data frames. Now in order to accomplish our result, we need to have the total orders and total amount calculated. Now total amount belongs to order items data, whereas the order date and order status belong to the order data. So which means these two data sets need to be joined.
Joining two data sets in Spark is probably the most easiest thing to do. All you need to do is use odf.join, which is the first data frame, dot join the second data frame, and provide the join criteria, which is based on the order ID. And equality is represented in three equal signs and not two equal signs. So you need to remember that and don't get confused during the exam. So I'm going to copy order item, order ID, paste it over here. Now, if you see, this has fields belonging to both order ID and order items and order database. Now, let me try to assign a variable so that I can use this joined data set for further processing purposes. Now, as you can see, join data frame has fields from order data frame and order ID data frame. Let's look at the next part of the problem. If you look at the problem statement here on step number 4, you will see that you have been asked to do multiple things at the same time. My recommendation is split this problem into multiple subproblems. Now, if you look at this, the question is asking you to do aggregation, it is asking you to do sorting, and also asking you to do data formatting and asking you to do this in a certain way, that is by using the data frames. Now let's look at each of these parts. So let's first try to do aggregation. Okay, and aggregation should be done on order status and order date. And then we will think about ordering and formatting. So let's get started. So I wanted to join data frame dot group by and the two columns based on which I wanted to aggregate. One is the order date and the other one is the order status. Good. Now I want to do aggregation, right? So the two things that I want to aggregate here is the total amount which is nothing but a sum of order item subtotal and the count of distinct order IDs. So let me copy the order ID column name. Now, as I suggested, I recommend you strongly to copy paste things. Let's convert them into columns using the call function, which is pretty simple. And then let's try to encapsulate them inside the count distinct method. Okay, this is going to fail, and I'll tell you why. This is failing because the aggregate method does not completely give clear instructions related to aggregation. If you look at the aggregate method, the first column that we passed, we did not mention any aggregation at all. Okay, so this is going to fail. Now, if you scroll up, Spark is going to show you why it failed. The reason why I did this is to show you how to understand from your failures. So if you look at this, it says expression order item subtotal is neither present in the group nor is an aggregate function, which means the order item subtotal is not supplied as an aggregation task to be performed by Spark. So let's try to do sum. Sum is an aggregate function. This is going to work. It's going to take some time because there are multiple files on which Spark needs to work on, and a lot of processing needs to happen in order to get you the data. And this also depends on how fast your machine is and how much data you have on your machine. So if you look at this, you did get the result, but not in the desired format. If you look at the order date, it comes in as numbers, and the order total has too many decimal places. So let's try to fix these two issues now. In order to fix this, all you need to do is use some more functions which are readily available. First, I need to round the order subtotal to 2 decimal places. And then let's check quickly if this is going to work or not. So as you can see, it does say 2729.04, which is 2 decimal places. However, our result is skewed. So let's try to increase the window size to see if that's going to help further. Let's run the same command again. This time you got a much better result. Now let's try to format the date. By default, the date was stored into MySQL as a big int when we tried to load the data from Scoop. In order to format date, we need to first convert that into a column. And when we convert one of the parameters into column, we need to convert both of them. And then there are some readily available functions like Unix from underscore Unix time. This function takes a big int and converts that into a string data format. When in doubt, always look at the Scala API. During the exam, the API is available, but I recommend that you remember as much as possible because the amount of time given to you may not be sufficient if you have to juggle between the API screens and these screens. Now, as you can see, the date did come in a formatted way, but it does not seem right. The reason is the big int had too many digits in it. We need to trim those down. We need to discard the last 1000 digits, which is milliseconds, and then try. For the exam, I recommend that you remember as many functions as possible. While it is not a difficult task to identify or find out the right function to use, it may be very time consuming. The data is written. You can see the date is formatted. However, the result is once again not in a pretty format. Let's try to find out the reason. As you can notice, the column names are printed as it is, but you don't want a column name like this. You want a column name that is easier to use and that does not occupy so much space on the header. Let's try to solve this or fix this issue by using alias names. Alias names while using data frames is very easy. All you need to do is call the alias function and give the name of your choice. Over here, let's try to name it as order date formatted. Let's do the same thing for the aggregation. Wherever we have the subtotal, let's say order or total amount. Let's use total amount. And then the count of distinct, let's say total orders. Let's see what happens now. I'm trying to store this in a variable so that I can use the same data set for future processing. And I'm trying to convert this into a date format so that when I do sorting in the future, the sorting happens on the date and not on the string. We have the result and it is in the desired format. As you can notice, the date is neatly formatted. We have the alias name. The whole result is in pretty format. Now remember, this is only showing the top 20 rows.
The order date in descending order, the order status in ascending order, amount in descending. This is a lot of ordering. However, the Spark data frame API makes it very easy to perform ordering on the data set, which is what I'm going to show you now. So ordering is based on 4 columns. So let me create some template for myself so that I can fill in details a little later. So I've put in 4 columns. Now let me fill in the names of the columns on which I want ordering. So copy this Okay, paste it. And then I want to order underscore status. The first one I want to order in descending. The second one is ascending. Ascending is the default ordering. The third column is total underscore orders, total underscore amount, and I want this in descending. And the fourth column is total underscore orders. I want to keep it ascending, which is the default ordering. Let's see if this works. It did, which means we have the result in the descending order. If you can see, we get the July 24th records and then the July 23rd records, and the subordering worked and everything works like charm. Now let's try to see what else is pending on this problem. So part A is about formatting and ordering, which is available. Let's try to store this result in a variable so that we can use that variable for further operations provided in the problem statement. So let me say var data frame result. I think I left the show method over there again, so I need to remove the show method in order to get the execution captured in a variable. See, it says unit equal to. This is not how you need to store the result. Okay, so let's try to store the result in a slightly different way, actually in the correct way, by removing the show method from the series of methods that we have called. Okay, as you can see, this ran faster, and I already explained you why it is before. Now if you can see, the data frame now has the order date formatted, order status, or total amount, and total. So this could be a schema when we are storing these files later. Now the second part of the problem is to do the same activity by using Spark SQL. Using Spark SQL probably is more easier for people who understand the SQL language a little better than the programming languages like Java or Scala. So for that, we need to first register a temp table. Now, should we register a temp table on the data frame object? Yes, we should. And let's name it as order and items. Now let's try to query this table by doing var SQL result equals join df.sql select star from order items or order and items. This is gonna fail, and I'm gonna tell you why. This failed because the SQL method does not belong to the join df. You need to remember that SQL method is part of the SQL context object. We have registered the join data frame as an order items in the SQL context in which the join data frame itself was created. So now when you say SQL result.show, you will see the top 20 records, and you will see all of the columns that were selected. Now let's try to refine this solution further. Let's do select star from let's try to do the group by part first, because we know we want to group by the order date and by the order status. So we're selecting order date and order status, and sum of, what's the column name? It's order underscore subtotal underscore something, right? So let's try to copy the column name. Order item subtotal, comma, count of distinct of order ID. Order ID. Let's hit enter. So this can potentially give you a result that contains order date, order status, and a string and a double. So let's wait for this to execute and then refine it further. Now this has executed, and as usual, just like our previous solution, there are formatting issues and the column names are C2 and C3. So let's try to fix these two issues at a time. First, let's try to what do we do first? Let's try to format the order total so that it has just 2 decimal places. Okay. Next, let's try to give an alias name to that, saying total underscore amounts, and we can give another alias as total underscore orders. Now let's fix the order date itself. Now just like you used a method called or a function called from underscore Unix time, you can use a very similar function. However, remember this is SQL and not Scala, so you don't have to use the double quotes all over, and just treat it like any other SQL. So I'm doing toDate in order to make sure when I do the sorting that it is sorted as date and not as string. So the alias is order date formatted, and then let's do show of the result. A beautifully formatted result in the way we want it. However, this result is not sorted, so we need to sort the result. Now sorting is much easier when you're using Spark SQL, because this is all SQL-like commands. All you need to do is use the order by and then provide the alias names that you have used for each of those columns. So this would be order date formatted, in the descending order, and then you have order status, which is in the ascending order. That is the default status. That is the default ordering. Total amount is in the descending order and the total orders in the ascending order. Let me show the result to you. See, you can see the result in the descending order of order date, and the other ordering will be provided. Let's try to show the result of the data frame as well, so that we can compare the SQL result with the data frame result. Now as you can see, the first record here is from 2014 July 24th, which is a cancelled record. 1254 something is the amount, and the first record here is also same, which means our solution worked, right? Now let's try to do the third part of the problem. So we need to do the same thing by using combine by key method. Now combine by key is a little more complicated method. However, this gives you more flexibility in terms of how you want to control the processing of this data and how you want to control your map and reduce operations. So let's try to begin this exercise by creating a combine by key result variable, and then I forgot the variable name for the joint data frame. So let's try to take the joint data frame object and extract the required data elements from it, so that we can create a pair RDD from a data frame. You can see map X. Before we get into this, let's try to investigate how the joined data frame looks like. Now I did this so that we can see how these elements are structured and in what order these elements are structured. This will help us extracting these elements and preparing a pair RDD from a data frame. So all you need to do is say X of the index of the element. Now what is the index of the element? The index of the element starts from 0. So order ID is 0, order date is 1, and order customer ID is 2, order status is 3, and so on and so forth. In this case, we want the order date, which is 0, 1, and then we need the order status, which is 3, and then we also need the order item subtotal, which is
I think it's 8 or 9. So let's try to. I think I'm going to use 8 or 9 maybe. Yeah, 9. Okay, so as you can see, the RDD is coming as any, and any. So now our goal is to take this and convert this into the format that we need. So let's try to confirm if the result is coming. Yes, I can see the result. I can see 4 fields that I wanted, and all I need to do now is to format this result in the way that I need. Okay, so let's try to say x1 dot to string, because string is enough. The second one is also a string. The third one should be an int, so I'm going to do toString dot to int. The fourth one should be a float or a double. Let me do double. Now you can see I have, from instead of any, I have string, int, and double, which are the data frames, data formats that we need. So now let's make it a paired RDD. How do we make it a paired RDD? For that, we need to make it a key value pair. Right now, 4 values is not a key value pair, right? So the first tuple or the first 2 elements should be the key, and the next 2 elements should be the value. That gives us the desired paired RDD, so that we can do paired RDD methods like combine by key. Okay, so now that we have the key and value, it's time to write combine by key. However, if you can see, we have an int and a double, but the problem statement is asking us to go do total amount first and then the count. So let's try to swap them. Okay, let's try to swap them by bringing the double first and then the int later. Now this will put us in the same sequence as the data frame result and the SQL result that we had in the past. Let's quickly show the result to make sure that we have the elements in the order that we need, so that we can solve the problem which has a solution which is consistent with the other 2 solutions. Good. So we have a key and a value. Both of them are tuples. So let's try to do a combine by key method. Let's start writing the first lambda function, which is the initialization function. For this, we're going to receive a double and an int, right? Those are the 2 values. So let's try to say x, and the data type is double and an int. Double and an int. And then this is going to return, and this should return a double, which is the double value, which is x dot underscore 1. Let's try to say x dot underscore 1, comma. Now I want to collect all of the order IDs in a set. Why? Because I need a distinct number of order IDs, and set, this property of a set or the behavior of a set is to distinct all the elements. So in Scala, creating a set is, set, open the brace, close the brace, in between put whatever elements you want. Here, because we're initializing, we are putting the first element, which is x dot underscore 2. Now let's define the second lambda function. The second lambda function does the aggregation within the partition. Okay, so this has the initialization value, and the initial value was double and set, as we have done in the first lambda function, and then it has every element um, in the row that is passed to you. So sorry, every row or every record in the element that is passed to you, right? Now here the row is double and an int. So now I'm going to do x dot underscore 1 plus y dot underscore 1, comma, x dot underscore 2 plus y dot underscore 2. I'm sorry, I need to say x dot underscore 2. So all I'm doing is taking the int and putting that into the set. Okay. Now let's try to do the combining phase, which combines the result set from each of the partitions and then gives you an ultimate aggregated result set. In order to combine the result set, all you need to do is keep adding the double set, and then this time you're going to get a very similar data type or a same data types from all of your partitions, because each partition is resulting in double and int. So that is why both the parameters x and y are double and set of int. Sorry for that. It is a set of int. X dot underscore 1 plus y dot underscore 1 plus x dot underscore 2 plus y dot underscore 2. The plus combines two collections and gives you a third collection. Here we're getting a set from partition, each partition, so we're combining and giving an ultimate partition, or sorry, ultimate collection, right? So let's try to look at the result and see what happens. Okay, you got the result. However, if you can notice, we got the total amount as we expected. However, we got an aggregation of order IDs in the form of a set. We need to extract the size of the set. Okay, that will give us the ultimate result. We got the result in the form of two tuples. Okay, so the first tuple had um, the order status and order date, and the second tuple had the total amount and the total order. So let's try to do x dot underscore 1, which is, if you can see, the first tuple has two elements, right? So I'm going to do x dot underscore 1 dot underscore 1, which means give me the first element of the first tuple, and then I'm going to get the second element of the first tuple. Now the first element of the second tuple and second element of the second tuple. Good. This should work. Okay, now I'm going to get the size because I want a single number. I don't want all the order IDs. I want the total of all the order IDs. And as I mentioned earlier, we have used a set in order to maintain uniqueness, right? Um, I don't think I should be doing any rounding, because I don't think you should expect any formatting related problems within the RDD in the exam, because formatting here is done using Scala. This is not to test your Scala skill, right? So let me not worry about formatting in the RDD function. However, always remember, you will be or asked questions very likely related to formatting of data when it comes to Spark SQL and Spark data frames, because those are Spark skills. Those are not Scala skills. Over here, the math.round function is a Scala function. I'm not using it because I don't want to waste further time in exploring something that is not relevant to the context of these videos. Okay, we have given up on formatting, so that is why you can see the result in a certain way, and I'm going to do ordering. Now, sorting in RDD is also complicated when you want to accomplish multi-directional sorting within a tuple, and when you have strings inside your tuple. Okay, if your sorting is based on same data types and it's all on same direction, then you can use the sort by method. However, given that our question is demanding us to perform the sorting on different directions on different elements of the tuple, it gets complicated. So to make it easier, I'm going to convert this result set into a data frame and use the favorite order by method, which is there within the data frame. We have done this in the past when we were solving the data frame result, but this time I'm going to convert the RDD result into a data frame just for the sake of sorting. Given that we do not have a specified schema, I have to use the underscore notation in order to represent the column names. So that is why I use underscore 1, underscore 2, 3, and 4. The first and third columns are in descending. Okay, so let's try to show the result to validate if things are working as expected. Okay, RDD result.show. This should show the result for us. Okay, so I got the result I desired. As you can see, the first order is cancelled and first record is cancelled 1294 something, which was same as earlier. So now I'm going to just store this in a variable so that I can use this for future purposes. So let's try to look at the next part of the problem. Let me go back to the blog again. The next part of the problem is asking us to store the result as a Parquet file into HDFS using a particular compression, that is Gzip compression. So let me copy the path to which the problem is asking us to save this. Go back to my Spark shell. Let me quickly do a show of the result, by doing a data frame result.show, just to make sure that the object we're operating on is in fact the right object. Yeah, this is going to take time, so let me pause the video for a minute and come back when this finishes execution. Okay, so this finished execution. So let's try to save this in Gzip compression, right? So for that, all you need to do is say SQL context.setconf spark.sql.parquet.compression.codec, and then we are going to set the codec as Gzip. Okay, so it's asking for Gzip over here, right? So you can see when you scroll down, I have given this solution over here. I'm not going to be doing each and every compression over here, technique over here, but I'm just going to show you Gzip or Snappy, and then you can do Gzip yourself. It's very simple. So let's try to say data frame, that is data frame result dot write dot parquet, and then let's paste the file path that we just copied. Okay, so this is going to take some time. So let me pause the video. Okay, so this has completed. So let me just confirm if the data has been copied to the specified folder or not. So for that, all we need to do is something is wrong with the video. Just give me a minute. Let me fix this first. Okay, I tried fixing it. I could not. But if you see, I have executed a command on problem one, and as you can see, I can see result 4a-snappy, which is a folder which we have used when writing the Spark code. Right, so let me just do an FS on that, an LS on that, and then you can see the files have been created, and you can see snappy.parquet, which means the compression technique that was used was snappy. Now you can do the same thing for Gzip, and you can do the same thing for all the results that we have obtained: the data frame result, the RDD result, and the Spark SQL result. So right now I'm just going to do Gzip. All you need to do is change the configuration to point to Gzip, that's all. And now I'm going to say Gzip and then hit enter. This is going to take a while. Let me pause the video. Okay, by the time I come back, it should be completed. It's still running, so it's done. Okay, so let me just do a quick ls on that particular folder, say Gzip here, enter, and then you should see so many Gzip files, right? Like see gz.parquet. So this is also successful. So compression is very simple using Spark. However, for the exam, you need to remember the right methods to call and the right thing to do. So let's try to do the CSV part now. Now, the 1.6 version of Spark does not have a built-in functionality to output the files as CSV. Okay, so we will have to do some extraction of the data and create a comma separated line for every record that we have on the data frame. So all I'm going to do is x of 0 plus, keep separating each of those elements with a comma until I get the desired output. Okay, so I know there are 4 fields in my result as we have done in the past, and I'm going to extract those 4 fields which are indexed from 0 to 4, 0 to 3, sorry, and then I'm going to do save as text file, and I'm going to say result 4a-csv and just hit enter over here. Okay, something is wrong. Oh yeah, so this should be in a tuple, and this is data frame result in the first place. Yeah, this is not a tuple, I'm sorry. So this is just a string of string separated by string of variables which are separated by a comma separated variable string. Okay, so let me go back to HDFS and do an ls on the CSV folder now, CSV, to see if we have all the files that we were supposed to stored in the HDFS properly. Okay, as you can see this time there is no what do we say, there is no compression. So let me try to do a cat on this file just to make sure that the data that we copied is correct or not. So as you can see, I'm showing you so many commands, right? Okay, this is copied wrong, so let me remove this. I'm showing you so many commands. Now you should be able to do all of these commands without help. This is very, very important for the exam. If you're not comfortable doing all of these commands and remembering all of these method names, then I recommend that you go back to the drawing board and learn. So, as you can see, the data is in fact copied in CSV. So you should go back to the drawing board and try to learn all these concepts before attempting to do the exam. Okay. The last part of the problem is to create a table in MySQL and export the CSV result set from your the resultant CSV file into MySQL. So for that, let me log into MySQL first. Okay, -u retail underscore DBA -p. Control C. I think I'm very tired doing this video for 40 minutes now. So let me try this again. MySQL -h localhost -u retail DBA -p. And then I'm going to do Cloudera. Okay, so let me use retail underscore DB database and create a table named result. Okay, so creating a table is very easy. Now I'm going to, because the table already exists, I'm going to drop the table first and then recreate it, so that to show you that the script that I put in the blog in fact works. Okay. Okay, am I getting this wrong? No, it's drop table. No, it is drop table result. That's all. Yeah, good job. Okay, now let me create the result table. Oh, clear doesn't work over here, right? Yep. Okay, so the result table is created. Let me do a select star from result just to make sure there are no records. Yes, exit from this place and write a scoop export job. So let me scroll down. I'll copy paste the scoop export job. It's a very simple command, pretty straightforward, but I recommend that you should have all of these by heart. It's the only way you can save time during the exam and reserve that time for some problems that you may get into. So it's a scoop table connect username. What's important is the export directory from where I'm copying the files, and I'm trying to copy from 4A and then the columns that I want to export. So as you can see, I've changed the ordering of the columns, so you got to be careful about that. Okay, the export job finished. Now let me quickly I'm exporting again. No, sorry. So let me just log into MySQL just to confirm whether the records that we were pulling in fact were pulled. Okay, so it's use retail underscore DB, not DBA. I'm sorry, folks. I'm very tired. Okay, so let's try to do select count start from result quickly. Okay, it's 3165. Now let's try to do data from result.count quickly. Okay, 3165, which means the results tallied. Okay, so this brings us to an end of this problem. There are still few more things that you can do about saving all of these files into different formats. But right now we have reached the end of this problem, and I'm going to upload more videos for the more problems to come. Okay, I hope you have enjoyed looking at this video, and I hope this makes a difference to your preparation. So let's go to problem 2 in our next video. Thank you. Bye.